How's that? So you have this alternating series, and you have consequently a series of questions, right? So you have to first show that the series is convergent using the alternating series test. Then you need the number of terms that are needed to approximate the series to within 0.01. And you also have to find the approximate value to within 0.01. Then you finally have to determine if the series is absolutely or conditionally convergent. So I just made a note here that you that part B also the latter part might be X to correct to one decimal place. Right. So both of these are like interchangeable. One decimal place meaning that there's 1 0 after the decimal point. All right, so let's look at the first part. So the alternating series test, right, states that if the limit as n goes to infinity of b sub n is 0 and b sub n plus 1, right, this being the next term, is less than or equal to the current term, then the series converges. So the alternating series test, right, our index here started at 4. So if I index shift it to 1, right, 4 going to 1, I have to increment all the k's by 3, right? So this is k plus 3, k plus 3, k plus 3, right? So I just did, it's called index shift. So what's our b sub n? Our b sub n, use another color here, is going to be this portion. Okay, so the limit is n goes to infinity. So let's check this first condition. So we notice that it's bottom heavy, right? Right, because you have a k plus 3 to the third, and we have k plus 3 to the fourth. So the bottom is going to blow up very rapidly, way more than this, right? So it's bottom heavy, the denominator blows up, it goes to 0. So the first condition is satisfied. Now, the question is the next term always going to be less than or equal to the current term? If this holds true, right, then this series converges. Okay, so it is bottom heavy, right? So it's going to constantly decrease, right? So both of these conditions are met, right? So this one is met and this one is met. So that's why this series converges. So that's the answer to the first part. So the second part, right, how many terms are needed to approximate the series to within 0.01? They got to approximate it. So the next term of the alternating series is going to be the error bound, right? So going back here, right? Our next term, so I'm going to add 1 to the k, right? So it'll be k plus 4 to the third, k plus 4 to the fourth, plus 400. And while I'm at Aki, I'm going to keep this as well. Negative 1 to the k plus 4. Okay, so switch back to another color. So you have negative 1 to the k plus 4, k plus 4 to the third, over k plus 4 to the fourth, what's that it? Plus 400. Almost forgot that. All right, set this equal to 0.01. Right, so the goal here is to solve for k. So what I'm gonna do, right, so we probably could solve this algebraically. I'm gonna use Desmos. So I'm gonna share my screen. Right, you gotta figure out where these two things intersect. One moment. All right. This is from a previous problem. I'm going to erase this. All right, give me one moment, please. Okay, it's ready. So we have -1, right, to the k plus 4. I'm going to put x plus 4. X plus 4 to the third. All over x plus 4 to the fourth plus 400. All right, then we have y equals 0.01. Okay, so the question is, why's the one on the top not visible? Here, let me test something. I'm going to erase this portion. Oh, here we go. So you leave the -1 right to the exponent part out. All right, here we go. I'm going to zoom in a little. All right, so we start here, go to the right. So I see that the green is starting to decrease. Look like they're about to hit pretty soon. Just keep going, keep going. Maybe I'll do better finding the x-intercept. Zoom in. Write a little more. Okay, so this point just stuck out of nowhere. It says 96. So 96 terms. So it looks like 96 terms. So then you want to add all the terms before it. So I would probably leave this up to your calculator. This would be the answer to the second part for part B. For part C, right, if the absolute value of a series diverges when the original series converges, then it converges conditionally. If it converges, then it converges absolutely. Okay, so we're going to look at this. So the question is if this blue portion, right, because we already know it converges from the alternated series test. The question is, does this converge or diverge? So if this blue portion converges, then it converges absolutely. If it diverges, then it converges conditionally. All right, so here are our options, right? So you have the divergence, or the M-term test, integral test, comparison, limit comparison, right? So on and so forth. So we already know it's not geometric, right? This theory doesn't have one exponent attached, so we can't use the root test. All right, so I'm gonna X that out. The ratio test may work, but is it necessary? Is there a quicker way, right? Right, we can't use alternated series because that defeats the purpose. So let's look at the interim test. So excuse me, if this thing, right, if the limit as n goes to infinity of this thing is not equal to zero, then it diverges. Right, that doesn't mean that it converges, but that means that it diverges. So if you put an infinity here and here, right, eventually use L'Hopital rule is going to go to zero. So it doesn't diverge. So that test doesn't help us. What about the integral test? All right, so you have to have the integral, right, of k plus 3 to the third, k plus 3 to the fourth, plus 400. So I mean, there probably are methods, integration by parts and whatnot, but this is very complex. I wouldn't use the integral test for this one. The comparison test might be nice, right? So you just go through these like no, 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 maybe. K plus 3 to the third. So I'm going to compare this with this thing. So now I'm going to add the 400 with it. All right, plus 400. So this, right, from algebra, you're going to get 1. Oh, this should be a 3. I apologize. Likewise, this should be a 3. Yep, 3 and 3. So from algebra, you're going to get 1 over k plus 3. Okay, so we know that 1 over k diverges because it's harmonic. So 1 over k plus 3, right? The larger the denominator, the smaller the number, right? So it's going to go this way. This thing diverges, so we don't know anything about this one. Interesting. Right, like had this diverged, we definitely could say that this diverges, but this is larger than this one. Okay, so go through these tests again. So divergence test fails. The integral test, right, we get the natural log of k plus 3. Which says that this thing diverges, right? So this diverges. This is smaller than it. So we have this with the comparison test, right? This diverges, but that doesn't say anything about this. We have to use the limit comparison test. So we have right, C is A sub n over B of n. If C is equal to 0, right, it converges. If C turns out to be infinity, it diverges. If C is anything in between, right, then it depends on B. Okay, so this is definitely our A sub n. We're gonna let this be our B sub n. So K plus 3 to the third over K plus 3 to the fourth. Plus 400. divided by this, so I'm really multiplying by the reciprocal, so times k plus 3. I forgot to add this as the limit as n goes to infinity. Okay, so k plus 3 times k plus 3 to the third, that's k plus 3 to the fourth. Over k plus 3, I'll make that a little neater for you. Plus 400. So limit as n goes to infinity. So let's use L'Hopital's rule, right? So we end up getting 1, right? Think about it, it's like 4k, 4k to 400 goes to 0 because it's a constant. All right, so the limit as n goes to infinity of this thing is 1. Right, this is the limit as n goes to infinity. So 1 is a number in between it, right? So our b sub n was this thing, right? We saw that this diverges. So the series itself diverges, or the absolute value of the series per se diverges. I'll just put in absolute value bars. So for part C, it converges conditionally. Here, I'll type it in. All right, I know that was a mouthful. Hopefully you got something out of it. Part B, that's the one I'm a little iffy about. I hope you understood the process behind it, right? The idea is that you want to set the next term of the series to be equal to the error, right? Because that's what the error is. So according to Desmos, it looks like 96, right? Which means that the sum would be this thing. So I'm curious, let me know what the answers, well, especially like what the answer to this was. Any questions or comments, uh, feel free to reach out to me. I apologize it took this long. Have a great one.